Hello friends, welcome to Power Electronics. Today we will discuss the single phase full converter, that is bridge type. Also we have discussed in previous class the midpoint converter. So as you can see in the figure that Vs is the supply voltage, Is is the source current, where I0 is the load current connected with the load RLE, where E is the battery or the generated EMF of DC motor. Four thyristors are here, T1, T2, T3 and T4. So how they will work, we will explain this in detail. Vs is the supply voltage, so Is the supply current flows through the thyristor T1, then it flows to the load RLE and then goes to the thyristor T2 and the back path it flows. That means that thyristor T1 and T2 conducts during the positive half cycle. Also when the supply changes, how the supply changes, minus plus. So supply changes, the thyristor T3 here and the thyristor T4 conducts. T3 and T4 conducts in the negative half supply. So we observe here that how the thyristor works. So at the positive half cycle, the thyristor T3 and T4 will not work because the negative supply is across these thyristor, both T3 and T4. Also with T3 and T4 will conduct, the T1 and T3, T2 will not conduct. Reason is that thyristor. So if you look at the graph, what we observe here, also we have to take one assumption. What we take assumption, that is load current is continuous. As you can see here, load current is always continuous. If thyristor T1 and T2 work in the combination, after they stop working, then the T3 and T4 will start conduction. If you look at the diagram, this is the VAB. As you can see, this is the VAB. If we take it at the negative side with a dotted line, then we will call it as a VBA. Also, if you look at the output voltage, the voltage first rises here, rises and then it falls to 0. But it is not actually 0. Why? The reason is because of inductor. Because inductor does not apply sudden change of current, so it still going in the negative direction. So same it works with the second supply. It rises, then it falls to 0 and then it goes to the negative and then again it rises and falls. Same waveform we have received in the output voltage. Also if we look at the current here, the current rises, it do not stop at the instant of pi. Here it is the pi interval, it do not stop at the pi. It goes, its conduction goes to the pi plus alpha. So it conduct to pi plus alpha. Same again, from pi plus alpha, it goes to 2 pi plus alpha. Then again it goes to 3 pi plus alpha. This is the continuous load current. If you look at the condition of the thyristor T3 and T4. T3 here at this small part here, T3 and T4 were already conducting. So as soon as the supply changes, here it positive and Vs is negative, the thyristor T1 and T2 starts conduction here. Again at the negative half supply, T3 and T4 conducts. Then again T1 and T2, then again T3 and T4 conducts. If you look at the current through the thyristor IT1, that is thyristor 1 and thyristor 2, what we observe that after a delay of firing angle alpha, what we observe that here the current flows through the thyristor T1 and T2. So you can see the current here. Current rises and do not stop at the interval pi, it goes to pi plus alpha. In the negative half cycle, the T3 and T4 do not conduct, so no current flows through it. Again with the delay of angle alpha, T1 and T2 starts conduction up to the 3 pi plus alpha. Also, if you look at the voltage VT1 and VT2, voltage across the thyristor, what we observe that after angle of alpha, we observe that it acts as a short. Why? Because the thyristor T1 and T2 are conducting. Also, what is the voltage across them at the negative? At the negative supply, if you look at here, during the negative half supply, there is a negative voltage across the thyristor. So this thyristor acts as an open circuit here. Here is negative, here this is positive. So what voltage appear across it? It is Vm sin alpha. So this is the voltage that appear across the thyristor T1 and T2. Same again with the firing angle delay of alpha, it acts as a short, and again the voltage minus Vm across this. Also, if you observe that T3 and the thyristor T4, at T3 and T4 the supply changes. Now this thyristor, the negative voltage is across T1 and T2. Why? Because the negative supply minus plus. This thyristor will don't work, act like a open circuit. The thyristor T3 and T4 are short. So what is the negative voltage supply across them? It is minus Vm. Also the thyristor T3 and T4 during the negative cycle conduct, so it acts as a short. Here again the negative supply minus Vm. Then again it acts as a short. So you understand this by how the graph works. Here the assumption again I am explaining that load current is continuous. T1 and T2 conducts, then T3 and T4, then again T1 and T2, then again T3 and T4, as you can see in the combination. Also, if we look at the load current, how to calculate the load current? Load current is V naught 1 upon pi, range is from alpha to pi plus alpha. That means the thyristor conducts from alpha to pi plus alpha. Vm sin omega t d omega t, so we will get 2 Vm cos alpha. If you take the value of cos alpha equal to 0, then you will get the value cos 0 1, that is 2 Vm upon pi. It is the maximum. Also, if you take the RMS value, that is 1 upon pi, that is root mean square. First you have to square, then mean, then take its root. So we have square this waveform, take the time period, and what we got, that here the average supply voltage is equal to the RMS value. So this we have seen from the graph. So what is the purpose of using the single phase full converter? First thing is that in the midpoint converter, what we have observed that there is a minus 2 Vm sin alpha, that is the voltage across the supply. When the thyristor T1 and T2 are turned off, you can see here it is Vm sin alpha. The voltage across them is Vm sin alpha. But in case of midpoint converter, it was 2 Vm sin alpha. So the advantage is that there is a low voltage across the thyristor, so the thyristor will not get damaged. So the minimum voltage is across the thyristor. But in case of midpoint converter, the voltage is 2 Vm sin alpha. Also in the midpoint converter, each secondary should be able to supply the load. As such, the transformer rating in the midpoint converter is double the load rating. This however not in the case of single phase. So these are the two advantages we observe. First is that the voltage across it is 2 Vm sin alpha. That means when we have turn off, when this thyristor act as a open circuit, for example here T1 is conducting and T2 is conducting. The voltage across the T3 and T4, because this is reverse biased, minus and plus, so it acts like a open circuit. So what is the voltage across this thyristor T3? This is Vm sin alpha. But in case of midpoint converter,